This video is about polar coordinates and polar graphing. So it's the first of our unit, and let's just get some definitions down. So first of all, the origin is a fixed point or called a pole, okay? And the thing is with polar graphing, everything is not like a grid like you're used to. It's all about concentric circles, okay? Here's one circle with one radius, two circles, this is two radii, and 3 and 4 and so on and so forth. Now the center, the origin, is called the pole. And when you get a coordinate for polar graphing, it's no longer x and y, but it's r and theta. And r stands for radius, that's the distance from the pole, so you count how many radii you need. Theta is the angle from the pole, and it's in radians, so you can refer to your unit circle for location of where those radians go. Or if you still haven't memorized, you can just go by memory. So let me show you how this works. So let's look at this problem. The coordinate is 3 pi over 3. So here's r and here's theta. And you have two things you got to do. First, you have to graph it, and then you have to give two additional names for the same coordinate. All right? Now, to graph it, it's pretty simple. Okay, so draw your xy axis, and notice it has a 3. That means I need 3 circles. So I'm going to go 1, 2, 3. All right? Pi over 3, if you remember on your unit circle, if you don't, just glance at it, it is in quadrant 1. So I know it's going to fall in quadrant 1. As long as you're in the right quadrant, you're good. So I know it has to go 3 radii out at approximately pi over 3. So I put a point there, and I draw my arrow. And that's how you graph it. It's that simple. Now, to find the two additional names, the first thing you're going to do is take your point and add 2 pi to theta. And this first one, you're going to leave r alone. So r stays the same, and you have theta plus 2 pi. All right? So in this example, r stays 3, and my theta is pi over 3, but I need to add 2 pi to that. So if you recall, when you add fractions, you have to have common denominators. So this becomes a 3, this becomes a 6. So 1 plus 6 is 7 pi over 3 and 3. So here's one new name for that same place on the graph. To find another name, you're going to find the negative of r. So you're going to take whatever r is and change its sign. And then instead of adding 2 pi, you're going to add just a pi to theta. So in this example, r was positive to start off with, so in this one it's going to be negative because I changed the sign. Theta was pi over 3, and in this I'm going to add just 1 pi, but remember I've got to have common denominators, so this becomes a 3 and this becomes 3. 3 plus 1 is 4, so I have 4 pi over 3. So now I have two new names for the same location on the polar graph. All right, let's try another example. Okay, so notice this one's a negative r and then pi over 6. So let's graph it first. So the radius is 2. So just because it's negative doesn't mean a whole lot initially. So I'm going to do 2 radii out, pretend that's a good circle, 2 radii out, and pi over 6 falls in quadrant 1. Now, the negative radius means I'm going to rotate it 180 degrees from where I think it should be. So if pi over 6 is really right here, I'm not going to graph it here because I have to rotate it 180 degrees, which makes it go down here. Okay? That's what the negative radius does. It rotates it 180 degrees from the original. So now we have it graphed, and now we need to find the two additional names. So on the first one, remember, leave r alone, take theta, and add 2 pi. So I'm going to leave r as negative 2, theta is pi over 6, and I'm going to add 2 pi over 1. Common denominator is 6, that makes that a 6, and that makes this a 12. So this is going to be 13 pi over 6. So there's one new name. The second one, I have to change the sign of r and then add pi to theta. So if r was negative here, I need to make it positive. Theta is pi over 6. If I add 1 pi, common denominator makes that a 6 over 6, so 6 plus 1 is 7. And there it is. There are my two names for the same angle that I started with. Let's try another one. All right, so look at this. This is a little strange. I have negative square root of 2 and 2.54 radians. All right, you can do this. Now, don't let the square root mess you up. If you put in your calculator square root of 2, you find out that that's 1.41. And so this is just negative 1.41. No big deal. Now, the radians and decimals, now let's just think about this. Way back when we started radians, we said pi is the same thing as 3.14, right? So instead of using the symbol pi, I can use the decimal. And I gave you these landmarks. 1.57 is up here, 4.71 is here, 0 is where it starts, and then 2 pi is 6.28. So now that I know these landmarks, well, where does 2.54 fall? Well, it falls over here in quadrant 2. Now, how do I deal with this decimal? Well, 1.41 is between 1 and 2, so I'm going to do 1 circle, 2 circles. And it's not going to fall on 1 or 2, it's going to fall between them, okay? Now, normally I would go right here, right? But I can't do that because it's negative, so I'm going to rotate it 180 degrees and make it go this way. Okay, that's because it's a negative radius, right? Now, procedure is the same down here. You're going to leave r just like it was, and you're going to take theta. Now, because the radian is given to you as a decimal, I'm going to take 2 pi. Remember, 2 pi in decimal form is 6.28. So if it's given to me as a decimal, I'm going to add the decimal form of the radian. So r is going to stay negative square root of 2, and I'm going to take 2.54 and add 6.28. And I get 8.82. All right. Now, here I'm going to change the sign of r, and I'm going to add just pi. Well, remember, pi in decimal is 3.14. So I'm going to take theta, and I'm going to add 3.14. So no longer is it negative square root of 2, it's going to be positive square root of 2. And I'm going to take 2.54 and add 3.14. And I get 5.68. All right, so there's my two names, and that's how you handle it when radians are in decimals. One more example. All right, radius is negative 10, and radian is negative 1.57. Okay, so let's think again about our landmarks. Now, if it's negative 1.57, remember negative angles go clockwise. So this is 0, this is negative 1.57, this is negative 3.14, negative 4.71, negative 6.28, right? If you're going that direction. So negative 1.57 we know is down here. Now, negative 10 radii. Now, instead of drawing 10 circles, you can just do, you can scale it, like make it nice and neat. So I'm going to scale it into 2 circles. I'm going to call this as 5 and call this one as 10. As long as you scale it and I know what you're talking about, you're fine. Now, if negative 1.57 is here and 10 is the radius, but it's negative 10, that means I have to move it 180 degrees. Well, look at that. That 180 degrees puts it back up here, way up here. So in a way, when you have two negatives, they almost cancel one another out, if you will. All right? But I wanted you to see how that worked. So it started at negative 1.57. I know I need to go to 10, but back it up 180 degrees, and that puts me right back where I was if both of them were positive. Now, to rename these guys, I'm going to follow the same pattern as we did before. Add 2 pi to theta, so I'm going to leave r alone. And remember that 2 pi in decimal form is 6.28. So r is going to stay negative 10. And now I have negative 1.57 plus 6.28. And I get 4.71. There's one name, another name for that same angle. And then for this one, I change the sign of r, and I'm going to add 3.14 to theta. So r is now going to be positive 10, and theta was negative 1.57 plus 3.14 gives me positive 1.57. There's my 2 points. So really, if you graph these 2 points, you're going to end up with the same exact graph we started with if you do all your math correctly. Okay, this gives you an example of all the different things you're going to encounter on your assignment. I hope that makes sense. We'll see you in class, and let me know how I can help.